Thank you. Good afternoon. Good afternoon. All right. So what we are going to talk about is building smart applications in AWS. And we had a great lunch. I'm not sure how many of you are really awake. Can I have somebody's phone number, please? One sec. Let's go and see. Let's call my wake-up routine and see what we can do there. Right. Let's try this. Yeah. Whose number? Who's? 988. Okay. 988 699 1802. Okay. Hey, are you awake? How has been this? It actually has, right? So let's try this. How has been this day so far? Yeah, wait, man. I will. I don't want them to read what I'm typing. This way I'm sure what I'm typing. All right. That's just a command that I typed. It's a small script, actually originally inspired by Eric Hammond. He's out there on Twitter. You can figure it out. He's a great fan of AWS. It's inspired by him. I just made a minor modification to it. He wrote it in Bash. I wrote it in Python. Big deal. So sort of, it's there, right? But what we'll do is it's going to do and wake him up. Right? It does what it does. So in the meantime, as we go along, you're going to get a call shortly, and just pick up the call when it shows up. Got it? Pick it up, put it on speaker. So what I typed there landed on a call right on his machine. Right? Just for the information, this is about 24, 25 lines of total code. What I did now is about 24, 25 lines of total code. And what I wrote on that command prompt is very simple, right? I said some command polycall, gave a number and gave the text that I wanted it to say. Lifelike speech gets generated, sent out to a calling engine. The calling engine basically makes a call and lands it. The net cost of that, and this call came from Houston, Texas, if I'm not mistaken, and the landing price of that call was sub 3 rupees. Sub 3 rupees, in spite of the international call. Right? If you, in the call center business, if you're doing call outs, customer support, etc., you will clearly understand that typical landing price of a call is 15 rupees. Right? So the business case is slam dunk, straightforward and simple. But look at the smarts, right? I mean, I actually just typed the text. We came up with something. If you all know how to concatenate strings. Anybody who doesn't know how to concatenate strings here? Good. So we all know how to concatenate strings. We know how to make a bash call. We know how to make an API call. We have an AI machine. A machine that generated voice out of text. A machine that can go, make a phone call and land it on somebody's phone. And you can done it concurrently. And remember, I don't have a single server anywhere, by the way. There is no server behind this. None. I ran it, called it from my laptop. I made 2 API calls, one to generate the voice, one to make the phone call, and it's landed. I mean, I'm going to show you some of these things today, later on. But that's what I call building smart applications. You can build applications without knowing a lot about AI. Right? And you can take advantage of this. And think about it, 18 months ago, some of these guys know that, I had no clue what this was, like absolutely none, and I'm standing before you sort of thinking or putting up a show that says I actually know AI. I really don't. If you want to know the guy, where is that guy? I don't know whether he's in this room. Julian Simon. He's not here, he's in the other room. Okay. But he's the guy. And right after me, he's going to do a nice session there where he's going to get into deeper, and tomorrow he's doing that workshop where he's going to go really deep and make you stars. But what we are going to talk about is, you don't have to be an AI specialist. The idea is we want to be able to build very sophisticated systems. And what we did at Amazon is we looked at that problem, right? And at Amazon, we have been working on machine learning and AI for 20 years. There's an IEEE Spectrum article that talks about 2 decades of recommender systems at Amazon.com, written by an author, or 2 authors, one from Microsoft, one from Amazon. Right? That's the article. And we've been doing this. And anytime you use a shopping engine from Amazon, you actually see it. You actually see recommendations run. You see, what you should buy. The pricing engine automatically making the most right suggestions. Both on the marketplace, both for the customers and for the merchants. It's sort of helping everybody, right? Optimization of logistics, so on and so forth. And that's something that we've been using. We figured out there is a good way to do and run our business. Now let's go back to 2005. In 2005, we have scaled and built one of the largest e-commerce systems, correct? By that time, it was already 10 years plus, and we knew how to scale technology, how to build technology at that point. We looked at the industry and said, you know what, the technology players are not supplying technology the right way. There is a better way to supply technology, and we built this thing called EC2, S3, right? People said, cloud, what is it? How many people, I don't know, will continue to say that today, but in 2005, when we launched cloud, it was basically because the technology industry did not understand how to give technology the right way so that developers can actually do things correctly. It did not enable developers correctly. It was more of a buyer world rather than a developer world. AWS fundamentally democratized it. It basically took IT infrastructure and said it democratized, just gave it to anybody. If you have a few dollars, you can start building something. That's what it did. Now we want to do the same thing for machine learning. So we have been building these systems, right? Recommender systems. This is Kiva Robotics. It's Amazon Robotics today. So this is a beautiful system. What it does is it's IoT, smarts, AI, etc. It runs in our warehouses. It basically figures out how to optimize warehouse logistics inside. It moves shelves instead of people moving in to pick up items. This is real, not some fiction, not 3D illustration. This is real. This is happening. There's a bunch of these YouTube videos that you can go to. But that's a product. There you learn a lot. One of the biggest business efficiencies in this, you compress the amount of density. So you increase the density of a warehouse astronomically. These are systems that we have built. We learned from it. A lot of algorithms in here. Then we also built this. Voice-driven, intent-driven conversations. A big fan in the US, progressively growing in India. Someone is talking about it in the next room. So on and so forth. Great device. Go build your own skill. How long does it take to build an Alexa skill? 8 hours? 12 hours? It is, right? That's about it. You can get a basic skill up and running. Today morning, my wife had an interesting idea. She said, Madhu, I need a skill because she has to constantly remind my son, Ajay, you got to go to school at 7:50. She starts it at 6 o'clock. Right? It starts with every 15-minute reminders, then 10-minute reminders, 5-minute reminders, 1-minute reminders. She said, Madhu, can you develop a skill where I'll say, Alexa, count down till 7:50. Correct? And Alexa will start every 1 hour, 15, like how a rocket launch works. I thought through it, right? It's not a very hard skill to build. And it's useful. If you step back and think about it, it's very useful. And you can build it. It's not very hard to build. It's actually very few lines of code. But it's buildable. And it solves a problem. One important problem it solves is my wife doesn't ask me anymore. You know why I have an Alexa at home? Every time the cooker goes, psst, she'll call me and say, Madhu, keep timer for 5 minutes. So you have to go to a browser, you go to your phone, 5-minute timer because you got to switch off the cooker after that. Now I said, instead of saying Madhu, just say Alexa. Alexa, set timer 5 minutes. You don't have to call me. Think about the friction you have removed. You're all guys in the friction removal space as developers. Look at the friction you have removed. You make people's lives happier. Right? Another AI technology. Here somebody's packing a nice box, putting it into a nice unit, real world unit, and what this unit does is it actually floats off and takes off into the air. Right? This is real world, not a simulated flight, actual flight footage of a drone flying, Cambridge, UK, going and doing delivery. There are 2 locations in the world where we do this at Amazon. So we learned a lot of stuff from this. We learned to understand optics, we learned to understand flight dynamics, we learned to understand optimization, so on and so forth. Nice algorithms that you learn, right? Stuff that we've been building for, so that's a dynamic airport, The guy actually comes and throws the pad, the drone figures out that's where I have to land and lands there, right? Nice algorithms there. This is the Amazon Go Store. If you have not seen this, you should not be in this conference actually. Right? So this is come in, walk, pick up, get out. I went to the store. Unluckily for me on the day I went, and the purpose of the store is very simple, right? To remove lines. What ended up happening is there were lines to get in. when they opened up. But yes, eventually it will go away. Very smart. A large part of this technology uses sensor fusion, optical cameras, and we're going to see some of these technologies that you can use. Can you build your own Amazon Go store? I don't see why not. Without knowing AI, I really don't see why not. Right? And we're going to see all the code as well in 25 minutes. So, seatbelts on. So what's AWS's mission? Put machine learning in the hands of every developer and every data scientist, because I am tired of saying that, man, I am only a developer, I don't know how to do AI. That's not true. It's possible, we can do that. Between today and tomorrow evening, if you're on the workshop as well, any developer should be able to do decent amount of AI. I cannot imagine you cannot do that, right? That's what we're going to do. So I'm going to talk about, so the way AWS looks at it, the ML stack is there are 3 layers. Way down below you have infrastructure and frameworks. This is for people who really know the science and the art of system performance. You're a sysop, you're a developer, you're a AI data scientist, you're everything like Julian Simon embodied into one, then you deal in this layer. Here you have machines, frameworks, AMIs, and then you deal with it, right? You know how to manage your cluster, get it going. The next layer is where you have platforms. Wrap the complexity of the infrastructure, wrap the complexity of the algorithm, give it to you in a hand-baked shape. That's the next session at 2:40 out there. The first one I'm going to talk about is simply using APIs, ML services offered by Amazon to go ahead and build very sophisticated stuff. How many of you here in this room were the people who were in the serverless session organized by CodeOps last year? 1, 2, 3. Okay, that's not bad. 4. Okay, so if you were here, Adrian Hornsby, one of my colleagues, actually presented. He did present on a few of these services. I'm going to talk about a little bit more about them. That's about it. Right? Customers running, so it's not like I'm talking fiction here. All these customers run machine learning workloads on AWS today in a very big way. Right? And we're talking like Pinterest, Twilio, Mapbox, Carnegie Mellon, OpenAI, Slack, Yelp, RNIB, Social Group, BuildFax. All of them are running today on AWS, doing very large things. Duolingo. Right. What is there in it? First one, we're going to look at vision. Amazon recognition, the ability for you to see. How to see stuff. You give a piece of picture, it can do object and scene detection. It can do facial analysis, facial comparison, celebrity recognition, image moderation, and text and image. It's not OCR, it's text and image. It can do all of that today, right? You give a scene like that, it'll give you, yeah, it's a city, downtown, metropolis, urban, building, right? You give a picture, it'll give you that decomposition. If you have bicycle, if I shoot this room, it'll actually tell me there's televisions here, there are lights there are people, I see a bunch of faces, I see chairs, microphones, speakers, it'll give you that. It's not hard. It's one call. In a few seconds, you'll get, not even a few seconds, like a few hundred milliseconds, you'll get a response with a JSON that shows you. I'll show you that, right? We're going to go through these slides faster first. Facial analysis, you get a photograph in there, it'll tell you there is a face, looks like a face, appears to be female, age range, smiling, appears to be happy, emotion state, wearing eyeglasses, wearing sunglasses. I actually wanted to do a demo where I wanted to click a picture of this room and say what is the emotional state of the room, but it was an afternoon thing that was not good for me, so I didn't do it. Right? Because anything you record as data should be stored as data. I don't like the idea of not deleting data, and I know the state will not be good, so I'm not going to do that. Right? Facial analysis. People who were here, that was Adrian Hornsby taking the selfie. It was the AWS user group meeting right after that, and we took the shot right there at Diamond District. That's 100 faces that are detected off the shot. Right? AWS recognition can pick up 100 faces from a picture simultaneously in one call, and it'll give you dimensions of every face. The whole face will be available as an array, every face as an image with all the information, whether what is their emotional state, what is their eye positions, what is their nose position, what is their mouth positions, ends of their mouth, the lip area, the 4 coordinates of the left eye, 4 coordinates of the right eye, right? The dimensions of the face, all of that. Wearing sunglasses, not wearing sunglasses, male, female. So you can actually take a shot and actually do what? Inventorize the room. Right? Facial search, so I can then store these faces, and then instead of asking the question I asked today, who were there last time, I don't even have to ask that question. I can just run the index and say these guys were there in the previous meeting. Correct? Facial search. Text and image. So this is another beautiful thing. What happens is you give a picture, you give it, it'll find some nice text like license plate, it can pick up some reading of a magazine. This is not OCR, as I said, it's text and pictures. Right? It can read that, give you the order of the text so that you can make sense out of it. Simple API calls to do that. image moderation, you give a picture, it will actually identify. Shadi.com uses this extensively. So Shadi.com, people create profiles and upload pictures. They upload pictures of Shah Rukh Khan, they upload pictures of Madhuri Dixit, they upload pictures of as themselves. Right? Male guy uploads a female picture, female guy uploads a male picture. Right? Sometimes inappropriate pictures. They used to have a large team that went and did good to go, good to go, good to go on pictures. Now they don't do that. They just analyze and there will be some error rates. So their workload dropped by a huge percentage because they don't have to do that. It's simple API call. Tell me, is this picture matching the profile that I have with me? Is this male? Is this a decent picture? Is there a face in the picture? Because you say, this is my profile picture, send a bicycle in there. Right? That's not appropriate. So that'll be a good one. Another one is celebrity recognition. Same thing. Like if you upload Shah Rukh Khan, does it recognize? It does recognize Shah Rukh Khan. It does recognize. If you're on IMDb, it generally picks you up. Right? Definitely. Wikipedia, most people it picks up. So anybody is a celebrity, most US politicians, etc. And yes, there are companies now working on Indian politicians, other country politicians, etc., etc. And the database is constantly improving and getting ready. But celebrity recognition, it not only will give you the celebrity who's on the picture, it will give you the URL on IMDb, Wikipedia, etc., so that you can actually build additional data sets on them, on who it is, what they are, what is their name. Right? Simple API calls. So let's look at an API example. This is, I'm actually using the command line interface here. AWS, recognition, detect labels, image, that's the image. That's the bucket, that's the image, and what do you see? It says human, people, person, these are the confidences. Detect labels, right? Simple. It's a command line statement. How do I do this in Python? How do I do this in JavaScript? We'll see that. Another example of detect faces, same thing, you'll see that. Now, Marinus Analytics, they have this app called Traffic Jam, which is to help people detect people who were kidnapped, human trafficked. They have 1 million faces in their database of people who are lost. So somebody finds someone, they want to validate, you can upload the picture and Traffic Jam will come back and give you an alert that says, this is a lost person. Right? Marinus Analytics developed the app, they index 1 million faces and you should see the response time. It's in seconds. You can do 1 million search index in seconds and it will come back and give you results. But that is just pictures. Now there's an interesting problem. Now look at that guy, he just walked out of the door. Right? He was facing backwards. Now look at the situation. If I give you a picture of him just leaving the door, you would not know whether he's leaving or coming in. Correct? Is there a way to know that? No. The only way for you to know that is you know the next frame of the video or the previous frame of the video. Frames. Or for example, I'm wearing a nice tennis suit, tennis racket in hand with a ball going like this. That's a pose. That's not playing tennis. For you to know you're playing tennis, you actually have to hit the racket on the ball. It has to go somewhere. Correct? That's the interesting part. Recognition video can do that. What it does is it cuts across frames to understand. So not only can it not do everything that recognition image can do, which is object and scene detection, facial analysis, facial recognition, etc. It can do object tracking, activity detection, and concepts. Apart from using just video information, it uses information which is spatial, temporal, and auditory to understand what's going on in the context. That's an example. So we got a dog, we got a person, another person, another person, another person, another person walking. The way this works is very simple, right? You stream using Kinesis video streams, an input stream. Your output will come back as a data stream from Kinesis. What is Kinesis? If you used a Kafka, you sort of understand Kinesis. It's a data stream on one side. So we have Kinesis video streams to stream video in, and we have Kinesis data streams which you've already used most probably before. So the output of that stream will be the processing out of the video. It just goes in, ingestion out, data out. Right? You have that kind of capability on recognition video. Now, let's go to the console. I mean, I actually wanted to do this, but videos, I was not sure of the network, so I have a screenshot here. Let's say this is a video that I've loaded. It identified 57 results, labels, and it identified one person on the video. All right? Now, when I see the results here on the console, and remember you can do this via API as well, but effectively what it does is, when you click on sunset there, it told you the frames in which the sunset can be found. Right? If you click on, let's say, mountain, it will tell you the frames in which mountain can be found. Campfire, for example, in this frame there is no campfire. So if you click on campfire, it will tell you the frames in which campfire can be found. It also says one people. Somewhere in this video there is a person. So let's say I select that. It will actually show you the scene in which the person is there and show you the frames in which the face comes up. Let's say there were 6 people detected on the video. You can actually look at each of their faces independently. When you click each of them, it will independently show you the frames in which this person comes up. You can actually build a facial library of people in a video and then find out in which frames each person was, and it's one API call. Now, how do I use this in my mobile app? Yes, you can. How? Because this SDK is iOS ready, Android ready, there's a Java SDK, Python SDK, JavaScript SDK, Golang SDK if you're really funny about it. Right? If you want to do that, yeah, all of that is available today, and existing calls will do that. That's how you'll say AWS is going to start label detection, and it'll go blah, 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 and it'll come back and give it to you. Fine. City of Orlando, working with the police and the people in Orlando City, now have started working on positively improving the life of the people in the city by identifying hotspots using recognition video. Classic example of how you can do it, but these are all very serious use cases. There are some very interesting use cases. Yesterday I was on a very interesting startup discussion, and the founder of the startup had a very interesting problem. He said, Madhu, I have a situation where in front of our house, I don't want the dog to come, my neighbor's dog. I said, no problem. Put a deep lens, put a Raspberry Pi with a camera, connect it to a stream. When a dog shows up, it will alert you. Correct? It's not hard to do. And it could be your kid's project, not your project. It's not a startup program. It's a kid's school project. Right? That's what it is. Then Polly. So the call that landed on his phone was from Polly. It generates lifelike sounding text. It can generate voice in 25 languages and 50 voices. Indian languages are not there, but Indian English is there. 2 voices, Aditi and Ravina. What you saw was actually the voice coming in Ravina, but you can actually have voice generated on all of this, and this is really lifelike, right? We're going to do that in the demo. You actually just use SSML, and it will actually generate a lot of control. You can control the pitch, you can control tone, all of that. We go to that. Duolingo uses that capability to generate translation. It helps you translate. You type what you want, it translates it, and subsequently makes a poly call, builds the voice, and says this is how you pronounce it. RNIB, they support people with handicap in reading, visually impaired. So what they did is they actually took license of 2 million books that they had, converted them to audio files. These were not available as audio books, converted them. These are books that they had, they scanned, OCR, called Poly, built audio files, and gave it to people who were visually impaired. We are very happy to support some kind of projects like that. Right? Again, use of deep learning, very easy to use. You can just, regular developers can get this done. Washington Post experimenting with Amazon Poly to develop voice articles instead of just print articles. Amazon Translate, neural machine translation. Fluent language translation. For example, you say, hello, what's up? Actually, I think I have that somewhere. Yeah. You say Amazon Translate text. Can you guys see this, or should I go back to the previous slide? You can't. Okay, I'll go back to the previous slide. You probably can't see that. You say, hello, what's up? Do you want to see a movie tonight in English? And then it gives you whatever it is in French. But the interesting thing is, what's up is not what's up. It's what's new. Whatever that showed up there, if you know French, you know what it is. I don't know. Right? That is what's new. What is new? That is not what's up. Context aware translation. Right? Again, a simple API call as I showed you here, it can actually do that. That's there, that's the thing. It's context awareness there. Hotels.com is using it to translate their websites across different properties that they're running. They're also using Comprehend to review and analyze what is going on. Transcribe goes from voice to text. You give a voice stream, you give a voice file as input, it can actually generate text. It'll take an audio, it will say, hello, this is Alan speaking. It can do that. The more interesting thing with transcribe is it understands punctuation. It knows there's a comma should be here. It knows there has to be a semicolon here. It knows voice changed and therefore I need to do a paragraph. It knows there was a gap in voice, so I need to time code it differently. It will give you the time code as it transcribes. It knows, so you know you have to talk fast or you have to talk slow. The same thing I can say can happen in 10 seconds or 4 seconds. So since it gives you the time codes, you know how fast somebody spoke as well, right? Not only that, it will also understand something more interesting. For example, along the speech I say, hey, my email ID is mdsudan@hotmail.com. It wouldn't do md, Sudan, at, hot, mail, dot, com. That's not what will come out. It know you actually set an email address and actually create mdsudan@hotmail.com as the email address. Difference, right? You said the same thing. I said .com. Is it .com or is it .com? That's an interesting difference. Same thing, when you use a website address, HTTP, blah, 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 it'll actually pick up the right web address and give you the URL as opposed to doing that. It understands all of this. The more interesting thing with transcribe is that you can add custom vocabulary to it. You just put a phone meme, you define what it needs to translate as, it'll actually do that. It's possible on the console. Comprehend is comprehension analysis, inputs, sentiment analysis, key phrases, language, again an API call. I think there is another. Look at that. So for example, I give a whole paragraph of text. It says, you know what, Newcastle Herald is an organization. More than 100 words is a quantity. Herald is an organization, so on and so forth. It'll actually give you entities, their topics, the breakdown of what they are, so that you can go ahead and do what you need to do, right? Topic modeling, Comprehend API, Clear Social is using it, Washington Post is using it, and Lex can build chatbots. I'm not going to go into Lex because he's more or less doing the same thing. If you want to understand how to build chatbots, we'll do another session some other day, but it's simple. You can use the console, build up a very, very simple, straightforward Lex, integration with FP Messenger, integration with Slack, integration with mobile apps, integration with your website is all available as simple API calls for you to drive it. Typically, you should be up and running in a console Lex chat in about 45 minutes to 6 hours, depending on the complexity of what you're doing. Very, very complex ones can take several days, right? That's the intent modeling. Once you've done that, the integration should take you only a day, right? That's the idea. So book a hotel, intent, utterances, prompts, fulfillment would occur one after the other. NASA Mars rover, you can chat with it via Alexa or using Lex chatbots. It's available for you to integrate and look at. Capital One is using it, etc. I don't want to go into this. Now I'll go show you guys some quick demos and some code. Somewhere in here is the code. Yes, let's try this. Are you guys seeing it seeable? All right, much better? Much better? All right. So this is a Jupyter notebook. How many of you know what a Jupyter notebook is? This is an AI conference. That's a bad question, but just I tried. Right? So some people did not raise their hand. For people who didn't raise their hand, Jupyter notebooks are basically interactive Python notebooks in which you can store documentation, code, etc., and share it. It is one of the most preferred tools of data scientists to be able to do, because they iterate very rapidly. So you write a piece of code, you try something, it will show the result right below. And then you can do something, it will show the right code below, and then you can keep iterating on your text. And then once you got your formula right, that's the code you want, you can just persist it, save it. It's very nice. If you have not used it so far, highly recommend it. I'm using a Jupyter notebook because it's easy for me to share. Jupyter notebooks are highly shareable. It's easy for me to share. All of this will be available very soon. I'm just finishing some of the extra demos that I'm going to talk about, and then I'm going to share it via the CodeOps team so that all of you can take a look at it and see how you can do this. It's just one file. Right? The first one is import Boto3, JSON, IPython, display, audio, image, because those are libraries I want. I'm going to just go ahead and run them. It ran, right? Now I'm going to invoke the poly service. I ran that, and then I'm going to go to poly, and I'm going to make a call. This call that I'm making, let me see if I can take it. You guys can still see it? All the way back? Good. So what I'm doing here is I'm asking, the code is simple, right? Voice is in, poly service. Remember the previous one-liner was initialization of the poly service in that. I'm saying describe voices in EN, IN. EN is English in Indian, right? And then I'm just printing it. One line, and then I'm printing it, right? So when I run that, you see the response. So this is what Jupyter Notebooks do. The output actually comes on the page itself so that you can actually see it, right? So a bunch of HTTP response data, but if you look at the JSON, it actually gave you two pieces. There is gender female, ID Ravina, ENIN Indian English, name Ravina, gender female, ID Aditi, Indian English Aditi. It's just very simple to make that API call. But let's see if we can get Aditi to say something. Here I'm going to ask Aditi to say, Poly service synthesized speech in MP3 format. Hello everyone, this is a simple demo of Poly using the voice Aditi. I'm going to print speech, which is basically the JSON output of what it generated, but I'm also going to use the audio library of IPython to actually play the audio, right? So let's see what happens now.
Hello everyone, this is a simple demo of Poly using the voice Aditi.
Got it?
Hello everyone, this is a simple demo of Poly using the voice Aditi.
All right, I gave the text, one call, right? One JSON construct, synthesize speech, that is it. And remember, this can be in any number of different languages, right? The voice Aditi is ENIN. If I use a different voice, something else will come. For example, let's try Joanna. This is the beauty of Jupyter Notebooks. When I run it again, it'll redo the API call, blah, blah, blah.
Hello everyone, this is a simple demo of Poly using the voice Aditi.
Right? Let's try Russell. I think I have it. Russell didn't work. Let me see. I think it's misspelled.
Hello everyone, this is a simple demo of Poly using the voice Aditi.
Got it? Fine. So we like that so far, but can we ask Ravina to say something?
I am happy in welcoming you all at AI Day Days 2018.
Now let's think through this very carefully. From the time I pressed Control Enter, how long did it take for the audio to take to play? Like that, right? That's real time. Remember, this call actually happened on the cloud. From the Jupyter Notebook on this laptop, I made an API call, an MP3 file was generated, it came back and played out of my laptop. Right? One line of code. All right, now let's have a little more fun. I got a little bit of a large paragraph that I want Ravina to talk on. Right? Let's look at the different controls I'm able to put on that.
I can speak in a higher pitched voice, or I can speak in a lower pitched voice. I can speak really slowly, or I can speak really fast. I can also speak very loudly, or I can speak very quietly. I have a secret to tell you. I will whisper it to you. I'm not human. Can you believe it?
Right? So, that's audio for you. Now we're going to do some recognition. Right? So first I'm going to show you a picture that's on the cloud. This is a nice picture. This is my wife standing there in front of the Uluru in Australia. That's a rental vehicle, by the way. Just in case you think I owned it. But I don't mind saying I own it. I own something like that today anyway. So that's just to show you, right? I mean, one line of code to show you that on that bucket. I mean, if you look at what that code is, where is that code? It's right here, okay. If you look at that code, what I'm saying is, I want the service S3, bucket name, Madhu downloads, image URL, blah, 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 inuluru.jpg, pulls it, displays it, right? One line of code, pretty much. That's to show you what is there. But now what I'm going to do is I'm going to ask recognition to recognize it. I'm asking the service recognition to initialize, saying in the bucket Madhu downloads that file, go ahead, and I'm asking it to do detect labels. That's the thing that's here, that's detect labels, right? I'm going to run that, and it's going to do something useful, hopefully. Now, it said confidence at 99%, there's a human in there. 99% there's people in there. I don't know what the difference is, but there is. Confidence 99% person in there, 93% automobile, 93% car, 93% transportation, 93% vehicle, 91% jeep, 74% dirt road, 74% gravel, 74% road, 57% engine, 57% machine, 57% motor, 57% asphalt, 57% tarmac, 53% van, 53% SUV, and 52% off-road. The rest was below 50%, so it doesn't show up. Label detection, right? Not bad, right? Good, that's what I thought. Now let's try the same image and see if we can detect any faces in there, because it said there is a human there, right? Now let's try that, and it says, you know what, face details, it found something. Bounding box height 0.0 to 0.5, it gives you the bounding box of the whole thing, and it says confidence 99% on that face, right? There is a face. If there are multiple faces, you will see multiple of this in a JSON array. That's all it is. It's very straightforward, right? And then it gives you eye left landmark, eye right landmark, nose landmark, mouth left landmark, mouth right landmark, pose, whether the person is standing straight, doing this, doing this. It's very interesting. If you have family photographs, right, you can actually run recognition on it and figure out who's slouching. And you can tell him, I can prove it with data. You don't stand straight. You know, right, there are some people who will actually stand like this in a photograph all the time. Don't know why. They just do. You can tell them, see, I have data. Right? It's not a bad thing. And these are cool applications. As soon as the photographer takes a photograph, you can quickly, immediately say, you know what, this is not a good picture. You should take it again. Simple app. Makes life easier. Very interesting. It gives you brightness and sharpness also of the picture. Detect text and image using recognition. There is nothing actually in this text, so almost nothing is going to show up. What it's going to do is it's going to come back and say nothing found, text detections none. But if there was a picture there, it will actually show you what was there in an array, right? Another demo I really want to quickly do is our translate, which is in a preview. So if you try to run this notebook without access to the preview service, it won't be able to run. But the demo text is, this is a great event connected developers, blah, 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 blah. Again, all that I'm doing is one line, boto3.client, service name translate. I'm translating it into German and French, just for the kicks of it, right? And I'm going to print everything here. I'm going to go boom, and it translated it. So the original text is, hello, this is a great event to connect with developers, love the engagement and contact. German is whatever, and French is whatever, right? Simple ways to build sophisticated smarts into your application, 2 minutes. Sophisticated smarts into your application that can make life really, really fun. Last demo, this is actually already run, but this is a comprehension demo. You give a piece of English, text, whatever, call a single call. It'll actually tell you what are the things that's going on in that, right? Now, it's hot and humid in Bangalore today is the sentence I gave. It said there are entities. It found Bangalore as an entity and today as an entity, right? And Bangalore is a location and today is a date. Ability for you to write comprehension. And you can imagine the amount of lines of code I'm writing in everywhere. All of this is the amount of lines of code. And as I said, I'm going to add a few more things to this, share this stuff with you guys. Have fun. I think I'll come to the end of the talk. Thank you all. Hope it has been useful. And you can build smart applications.